All right, hey guys, so welcome to your very first Chapter 3 video. This very first section in Chapter 3 should be a little bit of a review. It's on average rates of change and secant lines. It should, like I said, hopefully be a review for you guys. It's definitely something that you have learned along the way in math. So we're going to start out by talking about what average rate of change actually is. So the average rate of change is just a fancy way of describing the slope between 2 points. And you guys all definitely know what slope is. We usually say that it's the change in y over the change in x, or we call it the rise over the run. And back in algebra, you guys would find this slope by doing y2 minus y1 over x2 minus x1. We're going to make it a little bit more sophisticated now that we are in algebra. Or I'm sorry, we are not in algebra anymore. Sorry, we're going to make it more sophisticated now that we are not in algebra and we're in calculus. And instead of saying y2 minus y1, we're actually going to call that f of b minus f of a. And then we're going to do, instead of x2 minus x1, we're going to do b minus a. And the reason that we change this a little bit and we make it a little bit more sophisticated is because a lot of times in calculus we'll give you this interval of x values and we'll give it to you like this, as a to b. So a lot of times we'll give you this interval a to b and we'll ask you to find the average rate of change. And so we find the function value at b, the function value at a, and hey, those are just our y values, right? We subtract them, and then we do b minus a, and we divide those two values. So again, it's just a fancy way of doing slope, all right? It's definitely something that you already know. A secant line, you've probably heard this back in geometry, but a secant line is a line that connects 2 points on a curve. So we just talked the other day about a tangent line and how it hits a curve once. A secant line goes through a curve and hits it twice. The slope of the secant line is also known as the average rate of change. When writing the equation of the secant line, we usually use point-slope form. It's a lot easier than slope-intercept form. But in case you need a little bit of a reminder of what point-slope form looks like, it's y minus y1 equals m, which is the slope, times x minus x1. All right, that is our point-slope form. So most of your answers are going to be in that form. And in calculus, we don't have to distribute the slope and then move the y1 over. There's no simplifying it. You'll just leave that as your answer. All right, so let's look at what an actual example of this looks like. So we're going to let f of x equal x squared. Find the average rate of change of f of x over the interval -1 to 2, then graph the function and draw the secant line. Finally, write the equation of the secant line over that interval. So we are going to first find the average rate of change, which remember is just a fancy way of saying the slope. So we know that we need this formula, f of b minus f of a all over b minus a. So in order to do this, we need to know what a and b are. Well, a and b are the endpoints on our interval, which means a is going to be -1 and b is going to be 2. So when we look at our formula, we're going to do f of b, which is 2, minus f of a, which is -1, all over 2 minus -1. And then remember, f of 2 just means the function value at 2. So we're going to take 2 and plug it into f of x, which means we get 2 squared, which is 4, minus negative 1 squared, which is 1, all over 2 plus 1. I'm going to put some equal signs here. Sorry about that. So we get 3 over 3, which means the average rate of change is 1. Now, a lot of times, once I actually find that average rate of change, I go over to where I'm going to write my equation of my secant line, and I write m equals 1, because the average rate of change is just the slope of my secant line. So that's my m value. Okay? Then I want to actually graph my function. So if I'm just graphing x squared, we know that has a vertex at 0, 0. And then since the coefficient is 1, that's just our nice normal parabola. So I'm here, 1, 2, 3, 1, 2, 3. And there's my parabola. Now I'm focused on the interval from negative 1 to 2, which means from this point right here to this point right here. And if we draw a line through those points, we can actually look, even just from the graph, we can find that that's a slope of 1. I'm starting here and I go up 1 over 1, up 1 over 1, up 1 over 1, which matches with the average rate of change that we found from our formula. Okay, but here's our secant line. It's going through the graph. Now, in order to write the equation of the secant line, we need 2 things. We need the slope, which we already have, and then we need a point. Now, it doesn't matter what point you pick, but it's going to be one of your endpoints. So I'm going to go ahead and, since negative 1 comes first, I'm going to say that that is the x value for the point that I want. And I know if I plug in negative 1, I get positive 1. So that is the point that I'm going to use to write the equation of my secant line. So the equation of my secant line is going to be y minus y1, which is 1, equals m, which is 1, times x minus negative 1. Now this, I would never actually write it like this. I'm really just showing it to you guys that way. I would write it as y minus 1 equals 1 times x plus 1. I feel like you guys can know that minus a negative is a plus right away, but I'm showing it to you just in case. But this would be our final answer right here. This is the slope of or the equation, excuse me, of the secant line, which we can even tell just by looking at the graph. All right. Now, an application of this would be like this word problem below. So suppose you travel 200 miles in 4 hours. What is your average speed over this interval? Well, average speed is just another way of saying average rate of change, because speed is just a rate of change. So when we look at this, the average speed is just the change in the distance over the change in time. So that means 200 miles in 4 hours, which means your average speed is 50 miles per hour. Now, this was not a difficult question. I know you guys can do that. But what I want to tell you is that that just means that is your average speed. You were not going 50 miles per hour the entire time you were in the car. At certain points in time, you were going slower than that, and at certain points in time, you were going faster than that. This just averaged out to 50. So what we're going to do later on in this chapter is look at specific functions and figure out, well, can we figure out when we were going certain speeds or what we were doing at certain points in time? So hopefully that was a lot of review. Again, I'm sorry that I'm going to be out on Monday. I really don't want to be, but I have another training that I have to go to. So you guys are going to work on the next 2 pages of practice in your packet. And I just want to give you guys a heads up that the very next page in your packet, I'm changing the first 2 questions. All right, so if you guys take a look right now, question 1, I'm changing it to the function x squared plus x minus 7, and it's over the interval -1 to 2. And then for question 2, I'm changing it to the absolute value of x minus 2 plus 4. So if you guys look in your packets on page 2, you'll notice that these functions are different. So please make sure that you change them because otherwise your graphs are going to be way, way, way off of the grids that I gave you, and they're going to be way too confusing. So please make sure you've changed those 2 questions in your packet, and you're going to work on pages 2 and 3 in class on Monday. All right, have a great weekend. I will see you guys soon. Thanks so much for watching. Bye.